YouTube, so you can check that out. Again, if you were just coming in when I started this, please put your name and campus in the chat. That way I know who's here, as well as if you have a question during the review, please either raise your hand or just type it into the chat, and then I will address it. So I have a new tool since the last time I think I met with most of you, except for those of you that I met with last week. I can do all my drawing onto the Word document, so you'll be able to see me write. I'll talk like I normally do, but I won't have to switch on the camera to do individual or writing on a separate sheet of paper. So I think it saves a little bit of time, and it definitely is less wasteful as far as paper is concerned. So, all right. So again, I'm in the Allegheny review. I renamed this to 23 Spring because what's going to happen is as I write in this, it's going to save it. And so you can actually go and see my markups after I've done it. And so you can see a blank one. The original one, I think, is 16 Fall. So you can see how often these are updated. And then you can also see, you know, the markup I did for this review session. So anyways, this basically, these dosage calculation review tips, I borrowed these from your blueprint. So for each semester, the blueprint is pretty consistent. And I think maybe between the end of today and Thursday, I'll try and add in a copy of the blueprint, although I think it is in one of the Boyce campus folders if you're looking for something like that. If you're a North Campus, I don't have a separate folder for you on the OneDrive share folder, but if you look at Boyce, I think Boyce, hybridization of Boyce and Allegheny is what you're going to want to look at. Boyce, you have one specifically for you, but if you need additional review, then please jump into the Allegheny review because there's just a lot of overlap, and I'll go over the nuance that might be different for you as we kind of go along. So the first thing that I'll mention is make sure you know your basic conversions. Okay, you need to know these. These will not be given to you. You have to memorize them. You must know what these are. They will not be given to you. Now, for North, Boyce, South, you have a few other ones that I'm going to add in here. You need to know that 1 cup is 240 milliliters. You should also know that that's equivalent to 8 ounces. I should have said that first. Okay, so 1 cup is 8 ounces is 240 milliliters. You need to know that 1 pint is 2 cups, which is 16 ounces, which is 480 milliliters. You also need to know that 1 quart is 2 pints, which is 4 cups, which is 16 ounces, which is 960 milliliters. Okay, so you need to know those equivalents. It's helpful for you, for students at Allegheny campus to know those as well, but you don't have the same type of input calculation. We do more of the output calculation, so I'll show you examples of both going through this.
Shouldn't 4 cups be 36 ounces? 32 ounces?
Yes, you're right. Sorry about that. Thank you for correcting that. It helps if I write things out appropriately instead of just copying what I said before. So yeah, so 4 times 8 is 32. You got it. 32 ounces, 960 milliliters. The other thing is, if you ever get hung up on these things, pull up if you have a water bottle, if you drink a water bottle, if you have a liter water bottle, it'll sometimes say the milliliters and the ounces. So I have a Camelback a liter Camelback, it says, 8 ounces, and then just above it, 250 ml. Then it says 16 ounces, and just above it, 500 ml. These are things just to kind of relate to as you're learning these things. So, all right. Rounding rules. One of the things I'll ask you to do is just pay attention as I go through the reviews. I'll intermix when you're supposed to be doing your rounding versus not rounding. The times that you're not going to round are really just when you're going from metric to metric conversions. So like if I'm going from milligrams to micrograms, or micrograms to milligrams to grams, grams to milligrams, you don't round your answers. You just leave them as they are. And those are usually like your first 4 or 5 questions where it's just convert these questions. Now, if you're going from like cups to milliliters or pounds to kilograms, so you're going from household units to now a different system of measurement, like metric system, then you would want to round to the nearest 10th. Okay. So you're going to hear me say that a couple of times. That's a very common question. It's commonly missed because you end up rounding. The only time you don't round there's 2 times you don't round. When you're going metric to metric, just a simple conversion, convert milligrams to grams. And when you're calculating your drops, you can't give somebody a decimal drop. You just round to the nearest whole drop. And like I said, we'll go through plenty of examples of that. All right. Most of you probably feel the most comfortable with the ordered over have, okay, or the ordered over available. This originally used to say desired over have, and I changed that because it's not desired, it's ordered. This works for the majority of questions that you'll do throughout nursing drug calculations. However, there's a handful of times where it doesn't work, so it's good to know other strategies. The strategy I harp on the most, you'll hear me say dimensional analysis, but I'll intermix and I'll kind of utilize. But if you ever get stuck, if you have a good foundation, or at least a good understanding, a decent understanding of dimensional analysis, it can help you figure out problems that maybe you thought you couldn't solve. With the exception being like knowing, what your conversions are. That's what you have to memorize. The other things that you're going to be working on this semester, this is new, is the introduction of volume over time for flow rate, and the introduction of the drop rate, which is flow rate times drop factor, which is your drop rate. And I'll talk about those and give examples here as we move along. Okay, so let's go through and look at some of the examples. All right, so if you don't know this already, at the end of this is the typed out key. So the benefit of doing this review is I can show you some things, that way you know what we're looking for. Oh, and I should ask, if you're not currently speaking, please put yourself on mute. That way it doesn't affect the transcription when I post this on YouTube for you guys. Thank you. All right. So I usually don't spend a whole lot of time talking about the initial conversion things. I think if you're here in second semester, you've already done this going into if you're in second semester, you already went through this with first semester. It's just practice. There's plenty of review of that. So I'm not going to spend too much time talking about these. The only thing I'm going to say, though, is for those of you who are at Boyce, you're going to see questions, and you've already seen this before. So let me pull this up. And then North Campus, you'll see these as well. So give me just one moment. You're going to see pull it up. And then I'm going to add it to this practice set just for additional practice. It'll be good for you at Allegheny campus to see this as well. So you're going to see a question that kind of looks like this. So I'm just going to add this here. So it'll tell you to calculate the fluid intake for the following meal, assuming a glass holds 8 ounces. Okay. And one of the things you're going to have to do is figure out, okay, if this is where the bulk of your conversions are going to be coming from, is doing this. So you can see I already wrote out, solving these. You're not going to see 1/4. You might see half. Actually, you probably see what I'm sharing, but I just closed out of it accidentally. So one of the things you'll see is it'll say quarter glass. You'll probably see half, but usually it'll probably be like 1.5 glasses, 2 glasses. It should be pretty straightforward as far as looking at that. I personally wrote the 1/4 glass just to challenge you a little bit, make you struggle and go, how in the heck do I solve this? You would just take the 1/4 times the 8 ounces and then get whatever that is in ounces and then multiply by 30. And that's where that kind of comes in. So again, this is just converting ounces to milliliters, or cups to ounces to milliliters, pints to ounces to milliliters. Or because we wrote out what each thing is, like pint and cup and quart, you already know what those milliliters are. So you don't even need to worry about going to pints to cups to milliliters, unless for some reason you just kind of have like a slip and you forget. Then you can certainly do it that way as well. Notice that we didn't calculate a volume for the turkey sandwich. That's because the turkey sandwich is not liquid, right? So it's a solid. It might, even if it told you that they had a 3-ounce turkey sandwich, that's 3 ounces weight. That's not 3 ounces liquid. Okay. So I haven't seen that yet where they've weighed that. But if you ever look at food labels, everything's kind of in ounces. Okay. All right. Now for, here's a good example of when you would want to utilize rounding rules. Okay. So if I have a patient that's 131 pounds, what I'm going to do is I'm going to take that. So I'm going to show this to you 2 different ways. I'm going to show you this in the dimensional analysis way. Okay. And then I'll show you how I actually do it. Okay. So again, the value of dimensional analysis, even if it's not something that is a strong thing for you, it's just some toy with it a little bit. When you're doing your practice problems, when you're solving them and you got them right, just during your practice time, make sure you can also do it using dimensional analysis. You might find that it'll help you out, especially later on when you get to more challenging problems like on the NCLEX and other things. Okay. So again, if you've heard me do my reviews, one of the reasons why I like to set up a dimensional analysis question is because then I can see that I'm eliminating the unit I don't want and I'm left with the unit I do want before I put any kind of numbers. Okay. So that's where this kind of pays dividends. So 1 kilogram, 2.2 pounds. Now, for me, because it's become automatic, all I do is I see 131 pounds, I divide by 2.2, round to nearest tenth. That's how I do this. I don't set this up, dimensional analysis, when I'm personally trying to figure out how to convert pounds to kilograms. It's not what I do. But doing this in the simple conversion or breakdown of things hopefully can be helpful for you. Okay, so I'm going to take the patient's weight. We said it's 131 pounds. I'm going to divide it by 2.2. Remember, you do get a calculator. And I'm going to see I get an answer of 59.545454. Repeating, I look at the 4 to tell me what to do rounding wise, and I'm going to write 59.5. Okay, 59.5 kilograms. Now, you at Boyce North South will not see this next type of question. This is the fluid. This is actually the fluid output or recalculation, the replacement fluid, as opposed to, so at North, Boyce, and South, your question that correlates with what I'm going to do for number 6 correlates with this right here, calculating the meal utilizing, looking at the Jello, the milk, the coffee, the juice, that is going to be what you are calculating volume wise, milliliters. Okay. And then notice that it didn't tell you to calculate milliliters. You just need to know that. Keep in mind, you're in nursing, you're in medicine, medical science, and science uses, or medicine is science, and science uses the metric system, which is why you're doing all these conversions for the metric system. So for Allegheny campus, you're going to see a question that was going to look like this, where it's going to tell you for every 125 milliliters of urine that's out, you're going to replace it with 40 milliliters of water via PEG tube. Okay. Then it's going to tell you the output, and the output is 500 milliliters. So I always say this is the kind of like expected, or I even use the word theoretical. Okay, this is the actual. And then this is the replacement, because it even tells you. Okay, so there's another formula you can work with. You can actually solve this a variety of different ways. Some of you may have done ratio proportion. Some of you, me saying that is giving you nightmares of middle school, high school. So if you are sitting there thinking like, I don't want to do it that way, then I'm going to show you the way that I would set this up. I would take the actual output. So I'll just say actual out. I would put that over the theoretical out, and I would multiply it by the replacement volume. The reason that I'm hesitant to focus strongly on dimensional analysis with this is because everything's in milliliters. And so you're going to cancel out milliliters, but you're going to be left with milliliters. And so that can be confusing. So all I can tell you is that if you follow this strategy, so I'm going to take my actual output, 500 milliliters, over my theoretical output, the 125 milliliters, times my replacement volume, you will get the right answer every single time doing this. Okay. The way this will be written, that might be a little bit differently. And all I would do is take 500 times 40 divided by 125, and that's where I get the 160 milliliters. The only way that this is going to be written differently that might trip you up on the test is it'll say something like, if urine output for the last 4 hours is 500 milliliters, calculate the replacement volume if the replacement volume is 40 milliliters for every 125 milliliters lost. Basically, they rearrange the question or the problem. But basically, as long as you can figure out which one is the actual output, what did the patient actually void, you can find the replacement volume, which usually tells you replace with, and then find for every like how much was lost. For every amount that was lost, replace with this milliliters, and then what was actually lost. Okay. And you might be wondering, does it matter if it's 4 hours, 8 hours, 10 hours? No, that's just, you're checking it every 4 hours. And so it doesn't matter how much was lost in 4 hours, because if they're asking you to calculate a replacement volume, it's still going to be based off of the volumes, not necessarily the time. I hope that makes sense. The other thing you can do is keep in mind this. If you're replacing with 40 milliliters for every 125 milliliters out, okay, 500 milliliters is the actual output. So when you look at it, you're like, okay, 40 milliliters for 125, then 250 is 80 milliliters. 375 would be 120 milliliters, and then 500 would be 160 milliliters. So what I did is I just kind of rationalized through, or even you could even write this out and say like, okay, so 40 milliliters at 125, then another 40, then another 40, then another 40. You can break this down however you want. I put this together for you just to kind of help simplify this problem, especially if you get stuck and you're like, how do I solve this? Now you have a strategy. If you're at North, South, or Boyce, I don't think you're going to see questions like this. You're just going to see the fluid intake calculation, and maybe at some point in the future, they'll also do that at Allegheny campus. All right, so this next question, and I'm just gonna bump this down to the next screen. This next question is commonly missed because it tells you to calculate the amount of teaspoons. And most students calculate the amount of milliliters, and it doesn't tell you to do that. Now, if you're at North, South, or Boyce, it's going to say you are to administer 250 milligrams of dilantin PO, which is by mouth, and then it'll say you will give blank at if it's labeled as shown below. So it won't tell you milliliters and it won't tell you teaspoons. You need to know that you're calculating for milliliters. So how do you know? So this is also helpful because you might notice this when you get into like your ATI or when you get to the NCLEX. There's going to be a couple things that might, you might get stuck on. So one of the things you want to pay attention to is what are the mechanisms of by mouth? Well, you can have tablets, you can have capsules, and you can have milliliters, okay? Or cc's, but milliliters, okay? And then milliliters, you can break that up into teaspoons, tablespoons, cups, quarts, pints, however you want to do that. But remember, nursing, medicine, science, metric system, okay? It's usually what that goes. So if it doesn't tell you teaspoons, you would calculate milliliters. So 2 ways that I know. When I look at the label, first of all, tells me to shake well. So I know it's a liquid. Okay. I don't think you've ever looked at a Tylenol bottle that was like Tylenol tablets and it said to shake well before use. You probably, that probably wouldn't be recommended. Then it tells you it's a suspension. So suspension, shake well, those are all indications that you're dealing with a liquid medication. Then you look at your label for the strength. The strength is 125 milligrams per 5 ml. Okay. So that's how we know we're looking for milliliters if it doesn't tell you specifically what to look for. Now, Allegheny campus, you will be told what to look for. Okay. But North South Boyce, it looks like your test is very similar. It just they expect that to calculate milliliters or tablets or capsules. And a lot of it is just based off of what the label says. Okay. So I'm going to do this 2 ways. Okay. I'm going to do this the way that you probably would see it if you're at North, South, or Boyce, in that you're calculating the milliliters. If I'm doing this dimensional analysis, I'm going to take my order, which is the 250 milligrams. And I don't want milligrams. I want to convert milligrams to milliliters. There's 125 milligrams for every 5 milliliters, and I got that from looking at the label. When I do that, I get an answer of 10 milliliters. If you're doing ordered over half, you're going to take the 250 milligrams over the 125 milligrams times your quantity. Do not forget this. This is where most people forget, is multiplying by that quantity, because most people will just give us an answer of 2, which is good if we're looking for teaspoons. But if you write 2 ml, that is incorrect. Okay, that's 10 milliliters. Now, the next step is you can just convert milliliters to teaspoons. So I'll show you the long way. So 1 teaspoon is 5 mil. I'll write teaspoon. And so you get 2 teaspoons. The shortcut is, since we already know 5 milliliters is 1 teaspoon, okay, you can do this using just ordered over half, 250 milligrams. Oh, hold on a second. Yeah, be careful if you're clicking on things. I don't know if I can delete your drawings, Mara. So, all right. Unless you're trying to stop me from doing something. So 250 milligrams. And if I'm doing this ordered over half, 125 milligrams. And then since I already know that 5 mil is equal to 1 teaspoon, then that's how I'd set that problem up. Okay. And then you would just get 2 teaspoons. And the reason I'm doing it this way as well, in both ways, is because this way, the 10 ml one is probably how North, Boyce, South are probably going to see this question without it indicating how many teaspoons. For other for Allegheny campus, you need to pay attention because it might ask for teaspoons or it might ask for milliliters. Just make sure you could solve it both ways. All right, let's move down here. And then Mara, if you're able to erase your marks, please do so. That I don't think that's going to show up on the recording, but maybe it will. And it doesn't look like it's oh, perfect. Thank you very much. Okay. And the only reason I knew it was you, Mara, is because it said as you were marking. so I wasn't calling you out. I did. Sometimes you don't know that it's happening. So, all right. Plus, I didn't even know you could do that, to be honest with you. Okay. So the next thing is on this anxiety medication. You have Valium tablets, 5 milligrams available. You will give blank tablets. Now you might be wondering, well, how do I know if it's per day or per dose? If they want per day, it'll say per day. Other times they want to know what it is per dose. I would say 90% of the time they're going to ask you per dose. In the event that they ask you per day, it should be very clear on what that is. Okay. So I'm actually not going to go through this, but just keep in mind you can do ordered over half for these, and it's pretty straightforward what you've been doing. Okay. So let me get into some of the things because I don't want to run out of time. Some of the things that might be new for you. All right. The things that should be new for you is these flow rate questions. Okay. So these tend to be commonly missed because nursing students are looking for math where there is no math, unless you think of math in the form of just reducing an answer. And what I mean by that is, let's look at question 19. Okay. So question 19 says we have the patient is to receive 375 milliliters Ringer's lactate over 3 hours. What would you set the rate on the infusion pump to in milliliters per hour? Now, for North-South Boyce or North Boyce South, it's going to tell you what would you set the infusion rate to. So you need to know that when we're talking about infusions or flow rates, we're talking about milliliters per hour. Sometimes you'll see it written as CC per hour, but I think you know at this point that ML and C equals CC. It's the same thing. Okay. So we're looking for ML per hour. So what am I going to do? There's really no math here other than just taking the 375, the volume, over the time, 3, and then reducing that. So 3 goes into 375. We would say 125 milliliter per hour. And if you didn't know that off the top of your head, 375 divided by 3, just plug it into the calculator, you get 125 milliliters per hour. Where this can start to create some challenges is sometimes it'll say the patient is to receive, let me get my mouse here. The patient is to receive, let's say, 400 milligrams in 375 milliliters of Ringer's lactate over 3 hours. Okay. When we're talking about flow rate, all we care about is milliliters per hour or volume over time. We don't care about the strength of the medication. Yes, we care about the strength of the medication and that we're giving and delivering the correct medication. But as far as calculating a flow rate or an infusion rate, we only care about the volume and the time. And the example I give is if you own a blue car or a red car, it really doesn't matter because you're going to have to obey the speed limit regardless of the color, car, make, model, how fast it can actually go or how slow it really is. It doesn't matter when we're talking about rate. Okay. So the blue car goes 25 miles per hour and the red car goes 25 miles per hour. They're both going 25 miles per hour. Doesn't matter whether it's blue or red, if it's a Chevy or Ford, those things do not matter, just like the strength. So you might see that as an example. I think there's might even be a question that's similar to that. Maybe not. Okay. All right. So you would do the same thing for this for number 17. Okay. For this, you're calculating flow rate, right? What's flow rate? Milliliters per hour. But the challenge here is somebody decided to write it as minutes instead of hours. Okay. So the most straightforward way would just be to convert minutes to hours. This is why you needed to know that. You probably already know how to do this, but if you don't, if you ever flip flop where the 60 goes, notice that I wrote my hour at the bottom first, my minutes at the top, because I'm going to cancel out the minutes. I'm going to be left with milliliters per hour. So I know before I do anything, I've set it up right. And you also know that there's not 60 hours in 1 minute. Okay. And when you do that, 120 times 60 divided by 90, and you'll get an answer of 80 milliliters per hour. Okay. The alternative way of doing this is you can convert 90 minutes is what? It's 1.5 hours, right? So 1.5 hour. So you could have done 120 divided by 1.5, and you would have came up with the same answer. You might see a question like this, where it'll ask you how long it takes for a particular infusion to take. This is just knowing how to manipulate the problem. This is where dimensional analysis kind of steps in. And then especially when you get into third and fourth semester, you're going to do some like conversions for like units per hour to milliliters per hour. And it's helpful to know how to organize your questions in order to get to the answers that you're looking for. So like for this one, we have 500 milliliters is what's in the infusion pump. Okay. And we want to know how long it will last. And so what I do is I take this flow rate, the 125 milliliters per hour. What am I looking for? I'm looking for how much time, right? And I'm looking for to get rid of the volume essentially. So for every 125 milliliters per hour, this is how I would set up that question. Okay. So keep in mind that the first thing I did was I looked for what I'm like looking to eliminate. And you might be thinking, how do I know that I'm looking to eliminate that? You may not know that you're looking to eliminate that, but that's why we're doing these review sessions, because you'll start to see that I do the same things or similar things on most of these problems. And then hopefully you can apply it to other types of questions and problems. Okay. So 500 milliliters, infusing 125 milliliters per hour, and 125 goes in the 500 4 times. So it's going to take 4 hours for this infusion to complete. Occasionally you'll see a question that it'll say, it starts Monday at 11 p.m. What time will the infusion end? And you would say, Tuesday at 3 a.m. is when it would stop. You might see that. I've only ever seen that question a handful of times, but if you see it, and then also it'll tell you, write it in, military time. So it might be, it starts at 2300, ends at 0300 or 0300 hours. So you might see those types of questions in practice. Honestly, I haven't seen that too much, but you might see it on ATI, you might see it on NCLEX, which is why I'm mentioning it. The next thing that's associated with flow rate is going to be a modified version of flow rate, which is drop rate. Now, if you are at North, Boyce, South, okay, that probably isn't going to tell you the units that you're looking for. Just like I mentioned, the milliliters per hour, it may not tell you that. It might just say calculate the infusion rate. It might say the same thing here. It might say calculate the infusion rate. So how do you know drops per minute infusion rate versus milliliters per hour infusion rate? Well, two things will be given to you if we want to know if it's the drop rate. They'll usually give you a label, and the label will have listed drops per milliliter, or it'll say it within the context of the question. So it'll say your label reads 15 drops per milliliter or 15 GTT per milliliter. Or it'll say you're using microtubing. And for microtubing, you need to know that microtubing is 60 drops per milliliter. Okay, so that's your microtubing. So when I ask you what are the drops per, or what, calculate the infusion rate, and if we're talking about microtubing, that's what you need to know is the 60 drops per milliliter. All right. So for this question, and the other thing is, so flow rate is milliliters per hour, drop rate is drops per minute. The other little thing I'll tell you is that when you're calculating flow rate or drop rate, if your flow rate's already in minutes, leave it alone. If it's in hours, then you might want to convert it to minutes, or you need to make sure you do that. And I'll give you some examples of doing that. So the first thing is our tubing tells us, we look at the package, I circled it, 15 drops per milliliter. So we know what our drop factor is. Then we have a flow rate. Flow rate is typically milliliters per hour. Okay, but it could be milliliters per minute, and it could be drops per minute. So for this one, it tells me I have 75 milliliters and I have 25 minutes. Now, if I want to, I can certainly convert that to milliliters per hour, not a problem, but then you got to remember to convert hours back to minutes. So you might as well just leave it as 75 mil over 25 minutes. And then I'm going to take my flow rate. I'm going to multiply by my drop factor. What's my drop factor? 15 drops per milliliter. So before I do anything, I'm going to cross out milliliters. I'm left with drops per minute, which is exactly what we're looking for. So before I do any kind of math, I know that I've set this up right. 75 times 15 divided by 25 will give you 45 drops per minute. If it had given you, like, let's say it said, 125 milliliters per hour, just make sure you account for the 60 minutes. Another way that this gets missed is you'll have somebody, it'll tell you 125 milliliters per hour. And I'm just giving you an example. You don't set it up like I do. Like, you don't do the dimensional analysis, which is fine. You multiply by the 125 mil per hour, multiplying by the 15 drops per milliliter. Okay. You're kind of on the right track, but what you're going to do is you're going to get 125 times 15, and you're going to get 1,875 drops. You're going to write that down, and you're even going to write it down like this. Drops per minute, because you know your answer is supposed to be per minute, but you didn't convert that. You got to convert that. Okay. So if you see a number that's like bigger than 100, it's probably, you probably forgot to divide by 60. So you would just divide that final number by 60, and you'd get actually 31.25. So we would just say 31 drops per minute would be the correct answer. Okay. So don't forget to convert that to 60 minutes, or make sure you're dividing your answer or the whole thing by 60. Just keep that in mind. All right. So this question, very similar.
Sorry, hold on. That last one you just did, how did you come up with 31? And
because I took the 18.
Oh, okay. You took that and divided by
60.
60. Okay, so yeah, 31 wouldn't be correct. Okay.
Yeah.
Sorry.
Yeah, that's okay. No, thank you for asking. So like what I was getting at was like, that is not the right answer. We need to, and this will make more sense in the video versus if you're looking at this, just the paper, but you need to make sure you account and convert the time in hours to time in minutes. But thank you for stopping me. That's a good question.
Yeah, my brain just frazzled that, like you were saying, as if like that was an alternative, dividing it by 60 after you got that answer, you could still come up with the right answer. And I was like, wait, no. Shut up, brain.
No, it's okay. No, and that's a lot of times I add in these little things just because I know what's missed, and I've seen some of the answers, and I just want to make sure that you're seeing where it looks like you did everything right, but you actually did everything.
Right.
You missed something there. So that's, again, the value of setting it up using dimensional analysis. It's not because I think it's the bee's knees and the only thing that works. It's just because I can see before I do anything that I'm in the right units before I do any kind of math. So
Right.
yeah, good question. And thank you for stopping me.
Thank you.
Yeah, you're welcome. All right. And then and I'll also go through a reconstitution question. And then I'll also bounce back for reconstitution for Allegheny campus too. So here's another flow rate question. So again, it might not say, it might just say, what will the flow rate be? And then not tell us drops per minute. Again, that's north, boys, south, but on ATI and NCLEX, if you happen to see that, Allegheny students, then now you're getting some preparation. So again, how do you know it's going to be drops per minute? They'll give us a drop factor. So here you can see as I go down, it's 10. So I can circle that. It's really big, 10. Okay. But it's right there, 10 drops per mil. So, and I'm just going to write that over here, 10 drops per mil. That way I don't have to keep bouncing back. That's my drop factor. Okay. So we have a couple things. So first of all, we know CC is the same thing as ML. So you don't need to get hung up on that. Okay. So if I write this out, 1440 ml per 12 hours. Okay. So when you see this, it might be beneficial to go ahead and reduce this to milliliters per hour. I've seen students convert the 12 hours into minutes right off the bat, which is fine. So you would just take 12 times 60, which equals 720 minutes. Okay. And then you can rewrite this as the 1440 over the 720 minutes. Okay. So I'm just showing you alternative ways here. So scenario 1, scenario 2. But if you're going to reduce this, I would say do that before you do any kind of additional like math. There's nothing wrong with adding in additional thing. Yes. So if you are just coming in for 130, please put your name and campus in. And if you don't want to do it publicly, you can always just send it as direct message. That's perfectly fine. Also, if you want to ask a question, but you think it's going to be a dumb question in your opinion, not mine, you can also send a direct message and I will answer that question and not announce who you are, just so you know that. Okay. Don't just put your campus, put your full name and campus if you're writing things in here. All right. So all I would do is just 1440 divided by 12. I think that's 12. Yeah. So we're going to get 120 milliliters per hour. And then I don't like to do extra. I know, Alex, I know you're at CCAC. Which campus? Yeah. So North, Boyd, South, or Allegheny campus. Please let me know that. Thank you. All right. So I don't like to do like an extra conversion factor when I don't have to. We know that 1 hour is 60 minutes. So I'm just going to rewrite this as 120 ml, 60 minutes. And I'm just going to leave it as that. Okay. Oh, and Alex, because I'm going to miss it, please go ahead and just put your full name and voice in the same chat, please. Thank you. What happens is because there's so many messages, when I go through this later, I'm going to copy and paste and then pull out all the extra information because I haven't figured out an easier way to do this. And then that way, when I give it to your instructors, that way that can see, it'll make it easier for me. So thank you. All right. So we did all this, or down here, just to get to the, thank you, Alex, just to get to the the next step, which is just going from the flow rate in milliliters per minute and then multiplying by the drop factor. And again, we get that from the label, the context of the question, or if it says microtubing, now you know it's 60. First and last name, please, Tyler. Okay, so 10 drops per milliliter. Okay. And then I would do the same thing here, 10 drops per milliliter. And then I'm going to get the same answer, 20 drops per minute, right? Because we eliminated milliliters. We left with drops per minute. And if you're wondering, like, is this what I do when I set these things up? No, I am at a point now when I do a lot of these things, I can do it in my head to some extent, or I just plug in the numbers in the calculator and I know what I'm looking for. But they do ask you to show your work. Also, I find that if you're struggling with these, writing things down at least gives the benefit of two things. If you ask me later on, like you send me an email, how do I figure this out? And then I'll ask you to send me. So this will just be a caveat, or just to let you know, if you email me asking me how to figure something out, send me a picture of what you've tried to do already. That way I can help navigate or how you're trying to set this up. Yes, just like first semester, you are using a calculator on your test. So you'll get a test, or you get a calculator with your test on all 4 semesters. All right. So I just want to talk about this for Allegheny campus, and then I have an example that you'll see for Boyce, and I'll pull that up in just a moment. Oh, okay. Thank you for letting me know that. Yes. So yeah, if this is your first time taking these tests, then yeah, there is a calculator that you're allowed to use. It's a basic 10 key calculator that you'll be using. So if you're at Allegheny campus, this is what your reconstitution questions look like. Boyce, north, south, you wish that these were your reconstitution questions, but in a moment, I'll show you how to figure them out and it won't be so bad. But basically what you're going to do is it'll give you an order. So the order here is 60. You have the following 3 choices of strength after reconstitution. So it might be 5, 10, 20. And then it says determine the volume in milliliters for the strongest concentration. Okay. So what I'm going to do is you just need to know how to choose the strongest. So this is the weakest. This is mid. This is the strongest concentration. Okay. So if I'm going to do ordered over half for this question, I'm just taking 60 over 20 times my quantity, which is 1 ml, and my answer is just 3 milliliters. Okay. So, okay, so very good question. How did I know which one was the strongest? Let me ask you this question. Which one's the bigger number? Okay, if you can answer that question, right? Yeah, so that's how you know which one's the strongest. The bigger number is the strongest concentration. So let me put this in terms, in fun terms, right? So let's say I go, I'm at the bar, I'm at the place, I'm getting some fajitas, I want a margarita. Do I want the margarita with 1 shot, 2 shots, or 3 shots of tequila? Okay, I guess it just depends. Which one's stronger? The one with 1 shot, 2 shots, or 3 shots of tequila, right? It's the same thing. So more equals stronger. The only time this would get challenging is if like it said 20 milligrams per 10 ml, 10 milligrams per 5 ml, and 5 milligrams per, 0.25 ml, but you're not going to see that on a label, thankfully. And I'll show you what a label looks like because North, Boyce, and South need to know what those look like. The other concentration type question that you'll see is this question about Pfizer pen. And one of the things that you need to pay attention to, if you see this, and I have some examples of reconstitution labels on the OneDrive folder, so they're shared, so you can see those. A lot of times you're going to see where it tells you the milliliters of diluent added. You do not need to worry about that for calculating when we're doing concentrate or reconstitutions. All I care about is what is the strength. Okay. The strength for this Pfizer pen can be, there's three possibilities. It could be 250,000 units per milliliter, 500,000 units per milliliter, or 1,000,000 units per milliliter. So which is the strongest concentration? Okay. This is the strongest concentration, right? The 1,000,000 units per milliliter. So it'll, a lot of times the questions will ask you strongest concentration, determine how many milliliters. So all I'm going to do is take my 750,000 units over 1,000,000, and I'm going to get an answer. And this is going to be my final answer of 0.75 milliliters. Okay. I'm not going to round that to 0.8. Why? Because I want two significant numbers. And you also know that if you have a number less than 1, you want the two significant digits. Okay. And if you have a number greater than 1, round to nearest 10th. Number less than 1, round to nearest 100th. Just in case you get hung up on that. All right, let me pull up a practice question here for that's incorporates. Let me just pull it down here. Actually, I should have a blank space up here. Here we go. All right, give me one moment. Hold on. There we go. So for North, Boyce, and South, you're probably going to see something that looks like, let's see here. Okay, well, I guess I'm going to do it here. That's fine. That looks like this. So give me a moment. I'm going to clear out my markings and then talk about this one briefly. And then we'll be done with these for today. So you're going to see a reconstitution problem. You should have seen this already first semester. And then this will also be beneficial. So you won't see this at Allegheny campus, but I think it'll be helpful for you to see. So I'm actually going to change this to 625. I'm just going to create a new question. Okay. So a couple things. At North, South, and Boyce, you need to know that you're dealing with a reconstitution question. And you're going to see a question that looks just like this. If you come, so if somebody asked me about question 24, if you come back to the later review session, or if you come back next time, I will definitely do 24, but I won't be able to do that today because we're going to be finishing up here in 5 minutes. But I will address that question at another review. Just remind me if you come in the next review. All right. So the label for this is Kefsol 1 gram. Okay. But it tells me my order is 625 milligrams IM. Okay. IM only has one possible unit for delivery, and that's going to be in the form of milliliters. Okay. Intramuscular, right? Nobody's telling you to crush up pills and then inject powder into the muscle, right? That would just be bizarre. So keep that in mind when you're trying to figure out, like, what do I do with these things, right? The other reason, and the other way you'll know that you're dealing with a reconstitution is you'll go to your label, and for a suspension, it'll tell you milligrams per milliliter or grams per milliliter, micrograms per milliliter. Here, your label just says what? 1 gram. How helpful is that? It is not helpful at all, but it tells you it's for an injection. So again, it confirms that it's milliliters. And then we're going to look at the label. So when we're dealing with reconstitution, you have to look at the label. Again, this is for North, Boyce, South. You're not necessarily going to see this at Allegheny campus, at least not yet. All right. So it'll tell you for intramuscular use, add 2.5 milliliters sterile water for injection. That's just telling the pharmacy, or maybe even you, how much deionized sterile water to add to the powder that's in the bottle. And then you're going to shake it up. Okay. When you shake it up, now you're going to have a suspension. That suspension, the total volume is going to be 3 milliliters. Okay. That's helpful to know, but, and the only reason I would need to know that is if it didn't tell me the actual strength of the liquid. But guess what? It does. Tells me 330 milligrams per milliliter. So that's what you're looking for on a reconstitution type question. You're going to then just you can do dimensional analysis, or you can do what I'm going to do here in just a minute, order over half. I'm going to take my order, 625 milligrams. I'm going to take my strength, which is 330 milligrams. I'm going to multiply by my quantity. Okay. And I'm going to get, and if you're sticking around, I may have a moment. I may be able to work out 24. So just be patient. So 625 divided by 330 will give me an answer of 1.89. It's a number greater than 1. So I would take that 1.89 and I would round that to 1.9 milliliters. So a couple things to keep in mind with reconstitution. The label and the instructions part of the label will tell you what the strength of the concentration is. So if you're having trouble finding it, that's where you look. And if it doesn't tell you, so like, let's say I'm sitting there going like, well, how do I know what to do? You want to look for the approximate volume or the total volume, that 3 milliliters. So if you take the 1 gram or the 1,000 milligrams divided by the 3 milliliters, you're going to get 333.333 repeating milligrams per milliliter. Okay, which is approximately that 330 milligram per milliliter. So that's where that is. So the only reason I'm showing you this, okay, this is just an aside. This is just in case they don't give you the strength, but every label that I've seen as examples has had the strength written. Usually it's in parentheses right next to where it says what the total volume is after you add the sterile water. Okay. But notice I didn't use the 2.5 milliliters. I didn't even use the 3 milliliters when I was solving my equation. I just looked for the strength, just like I would look for the strength of like Dilantin, which was 125 milligrams per 5 ml. Same concept. All right. And then you would just mark on your syringe. I think you can do that. And then for 24, this is what you call a weight-based calculation. So you're just going to take the patient's weight in pounds, right? Divided by 2.2. So I'm going to take 176 divided by 2.2. I'm going to get 80 kilograms. I'm going to take the patient's weight times the 15 milligrams per kilogram. Oops. Stop. Okay. 15 milligrams per kilogram. 80 times 15 gives me a loading dose of 1,200 milligrams. Notice how it tells you then 300 milligrams per day. That's important to know, but it says for the loading dose. The loading dose is weight-based. That's what this is, the weight-based question. And then if you're solving this next question, make sure you convert so that micrograms and milligrams, make sure you're within the same thing. So this is really just a conversion question. So you have two pieces of information. You have an order of 500 micrograms. You have a available solution of 0.05 milligrams per milliliter. So this might be on your label. And so you want to convert either milligrams to micrograms or micrograms to milligrams. So if I'm converting micrograms to milligrams, okay, move my decimal point over. So 0.5 milligrams. That's what I have been ordered, divided by my available. I know there's lots of things here, decimals, but you can plug that into your calculator. 0.5 divided by 0.05 and you'll get an answer of 10 milliliters. North, I actually don't even know that you'll see this particular question at Allegheny either or anywhere, but it was just, I think they wanted to make sure that you were getting questions that included conversions. And so they're considered two-step questions. So anytime you see like something labeled in the blueprint as a two-step problem, just know that that means that you probably have to do a conversion like pounds to kilograms, and then a secondary thing like multiplying by 15, or you might be converting micrograms to milligrams, then doing the rest of the math. So, all right, so I'm going to stop there. I'm going to go ahead and turn off the recording here. I will be